So again, this is all in the notes, so you don't really need to take notes on this specifically, but it's all in the content library if you want to go back and look at it, or you can write it down yourself if you want. It's up to you. So the test format, you're going to have 2 questions where I ask you to find the domain for a function and to show some work for how you came up with that. Next 2 questions will be odd, even, and neither questions, again asking for you to show some work as to how you justified that answer. The next 2 questions will be just indicating whether something is a function or not. Then we have 4 questions about perform the indicated operation. So I'll give you like a couple of functions and ask you to do like f plus g or f minus g or times or divide or compose. I think were the 5 operations we talked about. I'll have 2 questions where I ask you to write the inverse in the same form as the function. So like if I give you a graph, your inverse should be a graph. Or if I give you an equation, your inverse should be an equation. Or if you give you a mapping diagram, your inverse should be a mapping diagram, etc. There'll be 1 question where I ask you to verify that 2 functions are inverses. And then the way to do that is using that f of g should equal g of f, which should give you x we talked about in class. There'll be 1 question where I give you a parent function. I ask you to describe the transformation that's done in order to get a specific resultant function. There'll be 1 question where I give you a parent function and the resulting function. I ask you I give you the parent function, ask you to find the new resultant function after some specified transformations. And then the last one is I'll give you the parent function as a graph and ask you to draw the resultant function and describe the transformation in order. So like, okay, so what did this do? It went left 5 and vertically stretched and yada, yada, That's what I mean by describe the transformation. Is that questions on that kind of stuff? Everybody reasonably clear as to what we're asking for? Okay. Again, hopefully it's not I don't want the test to be a big surprise. It should be pretty narrowly, I want to make it narrow and specific so that you're able to prepare well. At this point, if there's no questions about this stuff, I was going to open, yeah, Amy?
Are there any formulas that you need to know besides
Formulas you should know, the transformation pieces. So we described how to transform a point from something in the parent function to something in the resultant function. There's a way to do that, like xy goes to, bx plus h comma ay plus k. You probably want to have that. It makes, doing a problem like number 16 a load easier if you're able to just kind of do all the transformation at once. You should probably know, the general resultant function, like a times f of 1 over b quantity x minus h, plus k. You should probably know that form and what the a, b, h, and k do. But there weren't a lot of specific formula. You probably know the odd even definition, right? Even is f of negative x equals f of x, and odd is f of negative x equals negative f of x. But there's not a lot of specific formula stuff in here. Does that feel okay?
Yeah.
Okay. Aiden?
Transformations, when we have to list them out, does it matter if we do the A before the C, if we do reflect over x-axis, vertical stretch, and then reflect over y?
I probably wouldn't make a big deal out of that. Serge?
For the review, this is pretty much what's on the review, correct?
I don't think there's a lot of things here that aren't on the review. I think the review probably has things that are not on this list.
Okay.
But
I can do the review just fine.
I would think you'd be good to go. Okay. Should we move on to specific questions if anybody has anything? Dominic?
Right.
Ryan?
I have a question.
That wasn't even close.
I have a question based off the question from the review, if that's okay.
Sure. I'll pull up the review and we can look at it specifically. Does that work out with you?
Yeah.
Okay.
It was 1.7 continued C.
Okay. Yeah. 1.7 you said?
Yeah.
All right. So like what question do you remember?
Yeah, C and D.
This one right here?
Yeah.
Okay.
Can you just like walk through them? Because I was kind of confused on how you got the answer you got.
Yep. So what I'm basically going to do is I start by just removing the function notation, writing it as a y equals. And then I want to get the x by itself now. So in a case like this, where I have x's in two different locations, I'm going to cross multiply. And then we'll distribute the y through. And then I'll put the stuff with x's on one side and the stuff without x's on the other. On the right-hand side, or I'm sorry, the left side of this, now I can factor an x out. And if I divide both sides by 3 minus 2y, I now have the x all by itself. And then I can just swap my x's and rewrite this in function notation. Or swap my x and y, I should say, and rewrite in function notation to get this. And now, like, answers can vary a little bit on this, at least in the form, if you move things to the opposite side, maybe the signs are flipped or whatever. So you could differ by like a factor of -1 and still be fine, but that's the idea there. Is that okay?
Yeah, I was just getting something completely different.
Okay, so probably just like made a little algebra mistake or something. And then D would be the same sort of thing, right? Or do you want to do that one? Sure. So again, start with the y equals. And to get the x by itself, first thing I'm going to have to do is subtract the 8 and then divide by -3. And then we'll square both sides. I would probably go ahead and push the negative through to the numerator so I can just kind of forget about it. So I just swap the signs there in the numerator. That's why the 8's now positive and the y's now negative. And then I'll subtract the 2 over and then divide by the -5. And then again, like, then we'll rewrite this in function notation and drop the, or swap the x's and y's. X. And I'm actually probably would push that negative sign through. So maybe I'll write it in this order to get that out of there. And you could do some more cleaning up to make that thing a little bit nicer, but that's the gist of it. And again, on something like this, I wouldn't grade down if there was like, if you didn't do non-obvious simplifying. Like there's stuff you could do to get this into a single fraction and stuff, but It stinks to do it.
Because on
So,
the answer sheet, you have different.
oh, what do I have on the answer? Let me look. The question is, did I make a mistake or did I just like simplify it to a different point? Where did I use a logarithm in there
Yeah,
for?
that's what and I think
What great googly, this is just a completely different problem. No wonder you're confused by that. That doesn't make a lick of sense, Ryan. Okay. So yeah, we'll let's do that. So let me do that. I'll just do this for now anyways. And just move that over here. And sync. Okay. My apologies on that. I don't know what I did there. I must have decided on changing the problem halfway through and then didn't update the answers or something. I don't know. I have no good excuse as to what happened there. Amy.
Okay, so this might be a dumb question, but I'm just confusing myself. So like, when you go where it's like still the 2 minus 5x on one side, because you subtracted the 2 first, that's why you put only the 5 in the denominator?
Mm-hmm.
Okay.
Yeah. Lexi?
I'm a little confused on what the dot means between the negative 3 and plus 3.
Just multiplication.
Oh, so just, okay.
Just, why I put it there is so I didn't want anybody to think this was like negative cube root 2 minus 5x in case they saw something like this and weren't sure whether the 3 was the index or the coefficient. So I put the multiplication dot in there so you
Okay.
couldn't confuse it as like a cube root, like negative cube root instead of negative 3 times the square root. Is that?
Yeah.
Okay. Yeah. So just me trying to be more clear so you weren't confused and then in turn confusing you. So. What else do we want to talk about? Again, you can talk about things from the homework or whatever. It doesn't have to be just the review stuff, Jack.
So for the homework, how are you supposed to tell when it was 1 to 1 with an equation?
So probably the easiest way to do that would be to look at a graph. And you could certainly have just like typed that into your calculator and like looked at the picture. Would have been 100% reasonable on something like that. You know, like just, and if you're looking for justification, you just sketch what's from your calculator and show the HLT would be totally fine.
Thank you.
Yeah. Or you could demonstrate it even, like here's a specific x, or 2 specific x's that both have the same y coordinate, you know, and just give it numerically. That would be appropriate too. Is that okay?
Yep.
Okay. Amy. 54. Okay. So to prove these two things are inverses, we have to do f of g of x, and then we also have to do g of f of x. So in the case of 54, g of x is 7 minus 5x over 3. So when I compose that with f, I have 7 minus 3 times cube root, or I'm sorry, 7 minus 5x over 3, all over 5. Okay. So here, the times 3 and the divides 3 can cancel, right? Are you okay with what I did, Amy?
I'm just like confused on how you do that.
So what I did is I took my g and plugged it into the x for f. So like I have 7 minus 3 times g all over 5. So I did the composition. Is that okay? Okay. So then I'm just going to distribute the negative through. I can combine the -7 and the +7 to get 0. And then I just have 5x over 5, which is x. And in this one, there's really no need to show the opposite way because it's the exact same problem. Here, f and g are the same thing, so this one is, you know, you could just do something like this and be like, oh yeah, I'm done. Because g compose f is still that same thing, right? Is that okay? Lexi?
Can you go over 55?
Sure. So I can do still get. Hello. Okay. 55. So again, we got to do both compositions. So in 55, our g of x is -x minus 5 over x minus 1. And when I plug that into g, or I'm sorry, when I plug that into f, I have x, which is my g, minus 5 over x, which is now my g, plus 1. So far, so good with the composition?
Yeah.
All right. What I'm going to do now, my trick to make the simplifying a little bit easier, is I notice the denominator in each of the little fractions is the same, x minus 1. It'll always be that case for one of these compositions, which is nice. So what I'm going to do is I'm just going to multiply the numerator and denominator by x minus 1. This is equivalent of multiplying by 1, right? The nice thing is that when I distribute, it's going to get rid of the fractions inside of fractions. So when I multiply the x minus 1 to the fraction on top, I'm left with just -x minus 5. And then I'll multiply it to the -5. And when I multiply it on bottom, again, I get -x minus 5, then 1 times x minus 1. Is that okay? And now I'm just going to simplify, so I'll go ahead and do the distributing. In the numerator, -5 and +5 combine to get 0, and -x and +x combine to get 0. And I'm left with -6x over -6, which is just x. The other direction is going to work pretty similarly. This is your big time saver, though. If you do this, I think makes life considerably easier to do that simplifying, that little trick there, than trying to like make common denominators in the numerator and denominator and then like simplify that all down to one fraction in each and then multiply by reciprocals. Like, oof. That works pretty nicely. Check.
You can multiply by x minus 1 over x minus 1.
Yeah, because that's the denominator in the little fractions.
Okay. Oh, yeah.
So that's how I was able to figure out what to multiply by. It was just whatever that denominator is in the little fractions. In general, I'd be looking at the least common multiple of the denominators from the little fractions. But in a problem like this, where you're composing the same thing in for every x, the denominators will just always be the same. So it's whatever that denominator is.
What if the denominators aren't the same?
You'd use the least common multiple of them. So like, well, like if you 2 and 3, what's the least common multiple of 2 and 3? 6. So if they're you know, or if they
Oh,
would,
okay.
if you had 6 and 12, the least common multiple is 12,
Yeah.
right?
Yeah.
Or if you had, you know, like 6 and 10, your least common multiple there is 30, right? So it's kind of the same idea.
So you would just add to whatever, add like the factor to whichever one needs it.
Right,
So
you'd
you
have like the
2 and
product
then
of,
3, you would have 3 and a 2 down there.
you'd have, well, the numerator and denominator have to be the same, right?
Yeah.
But you're just going to take like, okay, you know, each prime factor that occurs, and then the largest exponent of each of those individual prime factors. So like if you have, like if you want the least common multiple of like, these two things, well, I see two distinct primes, x plus 1 and x plus 2. And the biggest exponent on the x plus 2, or x plus 1s is a 2. And the biggest exponent on the x plus 1s is a 1. So that would be like my least common multiple of them.
Okay.
Is that okay?
Yeah.
So it's the same thing you're doing with like real numbers. It's just like, you know, you have variable expressions, but it's the same concept.
All right.
Is that okay? Drake.
I have a question on like, number 48.
Sure. Okay. So all A, B, C, D, and E question, or like a specific part of it?
Just the inverse.
Okay. So doing the inverse for that?
and
Sure.
format that.
Yeah. So this is what? Part E, right? It's the inverse part. So I'd add the 9 over to start. And then I would cross multiply to clear the fractions. Okay with that?
Cross multiply
Yeah.
the fraction. Or all.
Just doing that, like what you'd use to solve a proportion. Is that okay?
Yep.
Okay. And then I'm just gonna FOIL out that right-hand side. And then I'm gonna move the stuff that doesn't have an X to the other side. So I'll have like minus 33 minus 4y equals xy plus 9x. And then I can factor in greatest common factor of x. And then divide both sides by y plus 9. And then you can just swap your x's and y. And if you wanted that written as a simple rational function where you have like the constant being added or subtracted from the end, you just would need to do the polynomial division. But that seems like a lot of overkill for me. I'm perfectly happy with the way it's written right now. I don't want to do that polynomial division to get into that other form. Yes, sir.
I have a question for like the test in general.
Sure.
Like, I'm looking at the review packet. Will we have to like find any discontinuities?
No. Eric?
Number 52.
52. Sure. So that again, that's A, B, C, D, E,
Yeah.
like the whole thing?
Yeah.
Okay. So it's a function. We learned that last year, right? You're good with that? And easiest way you could tell is just to type in your calculator and look at the graph, right? So it'd look, something like this. That passes a vertical line test. The domain, I know, goes from asymptote forward. So that asymptote was at 1. Because I know that logarithms have to be positive values. You can't take the logarithm of a non-negative, or of a non-positive number. So you can't do log of 0, you can't do log of negatives. So because x minus 1 was what was inside the logarithm, I just took that part and set that greater than 0, and there's my interval. The range for all logarithms is just going to be all real numbers. Again, I can tell that just by looking at the graph because I have an arrow pointing down and an arrow pointing up, and everything is connected in between. This is 1-to-1. I can look at the graph and see it passes a horizontal line test. So the inverse should be a function, since the original passes a horizontal line test. It's 1-to-1. And the last part would be to write the inverse itself. So I want to get the x by itself. I would start by subtracting 8 from both sides. Then I want to cancel out that logarithm. To cancel out a logarithm, I need to use an exponent base. The exponent base I'd want to use is the one that matches the base on my logarithm. When I write just log with no subscript, I recognize that as the common log, which is base 10. And the log base 10 cancels with exponent base 10. And then I just add my 1 over and swap my x's and y's. And there would be my inverse. Is that okay? Emily?
So I wasn't clear, like, when we went over the first part of the inverse. Can you do, like, a question of 29?
Yeah, it doesn't have to be, like, you guys at this point should be, should have done all of it before the test. Even if it's not all due yet, you'll definitely want to do all of it. So we can certainly go back in time. So 29 says we have we want to know a function f and g whose composition gives us this one in particular. So there's a couple of different answers you could probably give here. In general, the idea for something like this, what I want to do is I want to look for an inner part to my function and an outer part for my function, because when I'm doing a composition, I'm plugging like one into the other. So the natural inside part would be to say the x squared, and the natural outer part would be to the sine x. So my inner is going to be my g, and my outer would be my f. So my f of x here would be sine x, and my g of x would be x squared minus 1. And hopefully it's easy to see if I plug x squared minus 1 into sine x, I would get that function there. But there's a couple of others you could have done that are maybe a little less obvious. So you could do f of x is sine x minus 1, and then g is x squared. If I plug x squared in for x, I get my h of x. And then the ultimate cheat code on these is you can use h of x to be your f or g. and then the other one can just be x. Right? If you compose with with f of x equals x, it just doesn't do anything. It's like the identity function for composition, or the identity element for composition. Just like with addition, if you add 0, it doesn't do anything, or if you multiply by 1, it doesn't do anything. If you compose with f of x equals x, it just doesn't do anything. So you could do that as well. Yeah, so that's the whole idea. You're just kind of trying to find two functions that whose composition gives you, that thing. Okay. And again, there's probably more stuff past that if you were clever, and like things would have to cancel a little bit, but who has time for that nonsense? Those were easy enough to see. In my years of doing this, I don't think I've come across anybody that's tried to use something other than one of those three. So, Eddie.
So for a B on 107, I have the answer key pulled up.
Okay, so you're talking about the review.
Yeah, the review. I'm sorry.
That's okay. I just want to, and you're talking about questions.
Just wanted to question B on section 1.07.
Okay, so the 1.07 should have a question above whatever A, B, or C you're talking about, because I think there's a couple of questions in 1.7.
Oh, okay. So the question under B.
So this B, or this B, or
The non-continued one. Yeah, the B, go down.
so like question 8.
Yeah.
Okay,
Okay.
that's okay. I just wanted to make sure. Okay.
So yeah, so yeah, that one for B.
Mhm.
So I guess the first step that you have pulled up on the answer key.
Let's just look at the answer.
And then for the second step, I'm kind of confused how you multiply 2 times 4x plus 3 and then negative 3 times 2 minus 5x.
So I multiplied the top and bottom of the fraction by 2 minus 5x.
Yeah.
So right here, I multiplied that by 2 minus 5x over 2 minus 5x.
Yeah.
So I'm left with here, just that part, and then negative 3 times that, and then just that part, and then positive 4 times that.
I just didn't know that you can multiply something from the right and then back to the left side. Like how you can multiply that negative 3 that's on the right and then use that to multiply the bottom of the fraction.
Okay, so I'm not doing that. What I'm doing in here is I'm multiplying by 1. Right? I'm just multiplying the top and bottom of that fraction by 2 minus 5x. So like it distributes to both of those places and then clears out all the fractions for me, is what I'm doing there. Does that help?
That makes sense.
And that was the same thing we did on was it 54, 55 in the homework that we just looked at a few minutes ago? I used that same trick. In reality, whenever I'm going to do one of these like compositions that involve a rational, like 2 rational functions like this, I'm probably going to use that trick because it makes the simplifying so much easier to just like clear all the fraction out of there. Is that okay? Yeah. So again, not totally clear on what I did there. If you remembered that I'd used that trick, I think I did an example where I used that trick in class, but no big deal. Happy to clarify. I'm going to erase this out of the answer key though, so I don't want to gummy up all the answer key things there. Serge.
You told me that there's going to be no discontinuities on the test, so there's going to be nothing like question 3 at all in your part of the test.
So like this here? Yeah. Yeah, I went over the test questions on what I was going to ask. So I didn't have any discontinuity stuff in there, I don't think. Natalie. Certainly. Of course. Anybody else? Seems like we kind of wound down here. Okay. If you change your mind, you can always come up and talk to me. No big deal.